All right, there's no need to make this overly complicated. It is the most simple thing there is. Light is like this. These are a wave and a particle. You see the wave is because there's a big magnetic field. You don't see, it's like a bubble surrounding a tiny little particle. We accelerated that light. You're not supposed to be able to accelerate it. We accelerated it, and the particle right there, that little white stream coming out, is the actual particle gaining energy as it leaves the field, just like breaking through the sound barrier when a jet goes. This is breaking through literally the field strength. And it's pulling itself right out, accelerating fast as hell. And when it hits the Venturi, it explodes. And you say, well, what explodes? And I say the particle, which is this particle here, and I will show you that in detail, uno momento. Coming out here, you end up with Higgs fields. They have it totally backwards. They think the Higgs fields decay into particles. No, the particles come back together and create the Higgs fields. And here they are here. And this one here is the strangest of all of them. And that I have figured out how that happens as well. It's the only time I've ever seen it out of thousands of shots. This is light unknown to any physicist. This is the best they can do. They see a bunch of particles, and these are the smallest particles they've ever seen, which is the black one is always the same, and at the same size, the same weight. It's dark matter, literally, and they don't realize it. And it has a surrounding glow around it. We found these in our light experiments. These were done with huge colliders, billions and billions of dollars. This was done for a couple of $100. And this is a photon this is in the black and white, and this shows that this one here is much more energetic because this is behind the black. It's going this way, and if you might be able to see this, you might not. You see these little particles down there? It's crashing into those, glowing, and they make the other particle glow back. It's a push to shove. They both end up gaining energy as they push against each other. These gain energy, this gains energy as they collide together. Basically, that's what it boils down to. It's a collision of particles, and it's a collision of these fields. And again, this is it. Now, this shows you that this is fission and fusion. This is fission. The black broke away from the white. That's fission. When they come back together, it's fusion. There's no other way to look at it. You get the muon and the electron neutrino stuck together as a dirac. When they split in heavy water in a nuclear experiment, nuclear reactors and so forth, they end up with a sterile muon, which is the black one, and electron showers, which is the showers. That's it. That is the holy grail of energy right there. And we did it right here for zero. You shoot the laser through a Venturi, which is a restriction. It crushes the fields, just like hitting them head on. When you crush them sideways, they have no other place to go other than they get crushed, and they separate here because the Venturi is tuned to a specific place where it only allows the white to come through. The white can get big and small. The black, one size fits all. See that? These are Dirac neutrino. You got a black and a white, just exactly what I showed you, only it's really a dipole electron. All right, this is like a 2-minute to understand physics. It's that simple. There's a dark core, yes, and that is gravity, it's dark matter, and it's the reason we can never see the dark matter because it's always inside a cloud of electrons which bounce back at us. They're not dark, they're energetic and bouncy. The black does not emit, it doesn't absorb, it doesn't reflect. It just sits inside and attracts white to surround it, so you never can see it. The only way we could see it was because when we split them, it ended up being on top of the white, so we could see it underneath. You see? If it wasn't on top of that white, all we would see was the white. The black's in here too, it's all over the place. The only reason we can see it here is sitting on top of the white, obstructing the white from coming at us. Otherwise, you just wouldn't see it. It's all over the place. It's everywhere. But you only can see it if it gets in the way of the white. And you can only see it because we split it. And that's the way they can see it too. But they don't know what they're seeing. They're just seeing it. They call it particle zoo. And it is. It's just a glob, a mess of particles. We use this right here. We use these type of particles and split and broke the positive from the negative, basically. Think of it that way. They took these and just exploded everything. And every now and then they got a positive apart from a negative, but mostly they get things like this and things like that and things like this, and they just have no idea what they see. It's just a big blob of gook. But they know they can find these particles as the smallest particles that exist. We know they came from light. They don't know that. See, this is what education has done. It's destroyed thinking. It's called peer review. They will not let you speak or publish anything anywhere unless they agree with what you're going to say. And they will only agree with it if you say almost exactly what they say. You may twist a little twist here, twist there. Some of the silliest things you've ever seen. They're trying to get a little bit of a hook to it so that they can pretend that they're getting somewhere and get some funding. There was just one that came out a minute ago, absolutely unbelievable. I don't want to be nasty to the people, but it was, now that we figured out we can work with the laws of physics. There's no laws. Those laws are based on something that isn't even true. They have no idea. These are dipole electrons. And that's what a proton looks like. It's not just a dark core, which is positive, which it is, I agree with that. But it's not just a half a dozen or 20 or 30 electrons on the outside, little bitty tiny things. It's just as much of these as it is of the dark. They're dipoles. There's two of them, black and whites together. And when you get a series of them surrounding the black, there's so many blacks and so many whites, it becomes stable. And that's called a proton. And that's right here. And I believe it's at 1839 or so. It becomes pretty much stable. 1840 would be a neutron, meaning that it doesn't want to give one up or take one on. It's got the exact even number. Even numbers are neutral when they're exact. Even numbers don't have to be neutral, but when they're stable and neutral, that's a neutron. When it's a proton, it either wants to give one up or take one on to become stable. That's the difference between a proton and a neutron. And these are the only two particles that exist. And we were able to split the white from the black, which is to create electricity. The white is electricity. The black is just is ground. Black is ground. The white is electricity. It wants to get to the black. That's how electricity flows. We were able to separate those, as I showed you, creating true, raw electricity. These are the only particles that exist. And the white one here gets all different colors as it gets, stronger and stronger and stronger. It goes from red, which is kind of weak spin, and it goes up to faster, faster, until it gets up here, zip, it's just flying. And at a certain point, you hit the ultraviolet catastrophe, and they no longer even have any white. They're gone. And all you have left is a black. And that thing can hurt you. That's why gamma rays, X-rays, all that stuff. That's when you get up into that range where all you got is a black, and it whacks you like that. Photons are just back-to-back dipole electrons. This creates heat. That's all this is. It's heat. It's extra electrons. They will flow in if it's cold, and they're allowed to get in. When that thing warms up, they'll flow back out to wherever they are more allowed to be. When you turn a heater on in a house, electric heater, it's blowing out these right here. That's exactly what it's blowing out, extra electrons. Extra electrons cause heat. Heat actually creates weight. If you took something, like my buddy here, Caesar, and he weighs a pound, let's say, and you heated him up hot, he would weigh more than a pound. He'd weigh a pound and, let's say, a gram. This is just theoretical. He would weigh more. And then when he got cold, he would weigh less because there wouldn't be as many electrons in there. Each electron weighs approximately 0.0005854 atomic mass units. You multiply that times 1839, and you end up with 1, which is a proton. That should make sense. Play it a couple of times and you'll figure it out. Chemistry's got to change. Not a whole lot. Well, quite a bit. Space, everything in space is saturated with fields and things like that. There's no way in the world light does not slow down. It's insane. Redshift, obviously, throw that out the window. Space, time, distances, the Webb telescope, virtually worthless. It takes nice pictures, but you're not going to see how far back in time anything is. Because the universe is saturated with fields and particles. It's not a vacuum by any means whatsoever. And it's not homogeneous either. It's not like you can look this way and look that way and it's the same density. No, this could be very dense, this could be not dense at all. But no matter what, they're both going to be filled with magnetic fields and particles and photons. Photons come out of every luminous body and they saturate. It's called the cosmic microwave background. And it's photons that have slowed down so much that they're just basically like floating around, waiting to bump into something or have something bump into them. So they sort of glow in the background as they are getting bombarded by little particles winking on and off, exactly like Fermilab says. There is no empty space. It's a quantum soup. All the particles blink on and off like little bubbles on a root beer, is what Don Lincoln said. I'm not making any of this stuff up. This is all true. And anybody knows that there's no empty space. It's just ridiculous to think that. All right, this is a picture of this general region we are in, towards the moon, using a cell phone, CMOS, with whatever app, I don't know. He doesn't want to be involved. I can't get through to him. There's a guy named Dylan, and he sent me a bunch of pictures that he took with his new cell phone. He said, "What do you think of this?" And I said, "Wow." And then he just stepped back. Now, these are all fields. Those are magnetic fields. This, I don't know what the hell you got going on here. You got a pyramid, and it looks like Atlantis, and they're traveling back and forth. I don't know. Why not? It could be. Who's to say it's not? What's this doing on top of the moon? This is some kind of energetic action going on here. Anytime you see light, there's energy. This, I understand why this is blue. It's because it's forcing and crushing the light against it, basically. So it's traveling in that direction, is my opinion. And again, this is not... There's no way in the world light is not going to slow down going through it. It's just impossible. Absolutely insane to think that. Totally insane. This is a fabulous shot. Coming through the Venturi, it's like a 50-50. It's letting some of the black through, but primarily it's making the white so excited that the black is pushing the excited white ahead of it. You see it? It's just like pushing it like a wave, forcing the white ahead. Now the white is now concussing with other white only, not with the black. And it creates what's called a Whistler wave, way out here. You see way ahead of that wave? That shouldn't be way out here. That wave should be the first thing, but it's not. It's because there's so much vibration that it's rattling ahead of it, the white particles only. These are white particle pushing, not the black. There's no blacks in here. It's just a white. Very, very. This was amazing, to be perfectly honest with you. When I saw this, I freaked out. I freak out every time Rod sent me stuff. Rod Warren was the guy, and he doesn't want to be involved either. I haven't had any communication with him for years now, unfortunately, and I'm not sure why. But you know, what are you going to do? I can't push anybody to do anything. But I want him to have credit for this, because without him, I would have never known this. Nobody would ever know this. It's the most simple thing. He was trying to make a Venturi. He's trying to make a double slit experiment, and instead of using a flat plate, he used rounded nails. Actually, they were nails, and he had them so close together, trying to make that slit. But it forced all the particles to come into that rounded area and crushed them, and then made them explode. And when I saw these pictures, I mean, he didn't know what he did. He just thought, wow, these are cool looking. And he was seeing things in these pictures that looked like people's faces and things. I agree. I can't discount that. I didn't push that side of it because I was into the atomic physics part of it. He was looking at it like maybe he could see something living in that light, and I can't disagree with what he saw. However, I couldn't promote that side of it. Maybe that's why he was upset, because I wasn't pushing his side of it, and he's the one that discovered it. But, I just wanted people to understand we come from light. Jesus Christ said, we are light. We come from the light. You think I'm kidding? This is the Nag Hammadi text, just discovered in 1945 after being buried for 2,000 years at the time of Christ. These are his exact words written down by his scribe. And Jesus said, if they say to you, where have you come from? Say to them, we have come from the light. Say to them, we have come from the light, from the place where the light came into being by itself. Let there be light. It established itself and appeared in their image. Let's make them in our image. If they say to you, is it you? Say, we are its children. We are children of the light. We are the selected particles of light to become alive. We are the chosen. We are the children, the chosen particles of the living Father. If they ask you, what is evidence of your Father in you? Say to them, it is motion and rest. Energy and just laying around matter. It's motion and rest. Motion is energy. Energy requires motion. Rest requires no motion. There it is right there. And he also said, whoever has come to know the world has discovered a carcass. You see this? Jesus said, whoever has come to know the world has discovered a carcass. And whoever has discovered a carcass, of that person, the world is not worthy. Now he talks about the carcass. Is that the carcass meaning the world, its population, and just the whole shooting match, or the body of the world itself? It doesn't matter. They're both carcasses as far as I'm concerned. And then he does talk about the body. Very interesting. He puts such an importance on this. Jesus said, whoever has come to know the world, again, know the world, has discovered the body. And whoever has discovered the body, of that one the world is not worthy. When you find the world, the earth, the world in its totality, you will find body parts in the body. You will find and discover the body, basically anatomy. I don't know if that's what he means. He talked in these ways, you're not sure what he's saying. But he did say, don't stop looking. This is the Nag Hammadi text, discovered in 1945. The words that Jesus said while he was living here, and Didymus Thomas wrote them down. Now, Jesus said, those who seek, meaning you better damn well seek. If you're not seeking, who cares about you anyway? Those who seek should not stop seeking until they find. When they find, they will be disturbed. When they are disturbed, they will marvel and will reign over all. And after they have reigned, they will rest. Jesus said, know what is in front of your face, and what is hidden from you will be disclosed to you. For there is nothing hidden that will not be revealed, nothing buried that will not be raised. We've seen a lot of these statements in other texts and so forth in the Bible, and they're all different places, associated to Jesus. And here it is. He's saying these things. These things ring true to me. And they point out that academia is an issue. And it's the problem we're having is trying to understand reality and being pushed back against reality by the ones that are supposed to be teaching us reality. They're the ones teaching against reality. And if we can get the energy that I'm talking about out of this, we may be able to get free energy in a lunchbox like that. Safe, free, clean, portable, and just run forever. As soon as you turn it on, you never have to turn it off. It would refeed its own self and spit out raw, clean power here. If you take a car and it's 4,000 pounds and you fill it with electricity, it's still 4,000 pounds. You drive it all day long, it goes empty again, it's still 4,000 pounds. You fill it back again, still 4,000 pounds. The white has no weight. So you're not like carrying a whole big thing around here. You're just carrying this, and when it makes the white gets used as energy. You could carry this around the woods, put it in your car, drive your car, do anything. For airplanes, the amount of energy that should come out of that should absolutely be staggering. This is electron showers. They come in at almost no energy whatsoever. And as soon as they go to the shower mode, zip, that little U means energy. It went from, 50 or 100 up to 3,000. That's a pretty good increase. And all we did was put a Venturi in there. We didn't add any energy. We didn't do anything special. This would take some, engineering to do it correctly and have it last a long time, where it wouldn't degrade the Venturi, and there's a bunch of little other things. A correct amount of harvesting, and then you have to regulate the power and so forth. But very, very minor stuff. I'm talking off-the-shelf stuff. Good engineers should be able to get this thing set up to go if it worked within 2 weeks. 2 weeks we could have energy coming out of these things. The stuff is all off the counter right now. It's right on the shelves. All they got to do is put it together. But you got to have somebody who knows what they're doing and get it accepted. I can't do this. They say, "Oh, why don't you just do it?" No, I can't. I'm showing you it can be done. What do I have to do it? That's acceleration. That's raw white energy. This is where we should be spending our money. Why should we say, "Oh, no, you're going to come up with that, you got to do it"? No, I don't have to do it. And it's never going to get done because nobody else will do it. So now, hopefully, Trump is, I'm not 100% with what he's doing. I got to be honest with you. Some of the stuff I think he's off, he's doing it too fast, too quick, and without thinking of the ends of the consequences. I would start with the reality of truth and what physics is and what our history is and about God. And then that whole scenario right there should make a huge difference in society. When they realize that God and all that stuff is validated and that we have been taught just nonsense, and the giants and dragons and all of the things that were written in these ancient texts were true, the Great Flood, all of that stuff. That will change society instantly, overnight. It should change as far as I'm concerned. But and the only way to do it is to get it out into the open. Somebody like Joe Rogan or some basketball player or something to talk about it. Reality means nothing unless you can get it out to the people. And they can crush you and force you not to speak. And when you do speak, they can somehow silence you. Let me put it that way. They've been very, very successful. Forever. And it just happens. That's the way it works. I think I told you about this. This article just came out. And I know what they're trying to do. They're trying to get funding. Everybody is in business now as an academic to try to get funding, to say, "Oh, we don't understand any of this stuff, so give us some more money, another 20, 30 years, we'll figure something out." Now, this is from Queen Mary University of London. And they're talking about superconductivity without the cold. No, it's impossible. It cannot happen. Cold means you've pulled all the electrons out. Remember I told you the black and the white together, one of those is a dipole electron, and the more you flood in, the more heat you have. Well, to get superconductivity, all it means is you've gotten so cold that there's no more heat in there. There's no more electrons in. So it becomes superconductive as soon as you hit it with electricity. But as soon as you hit it, they flood in, and then it starts to get resistive again. You cannot stop that. It's impossible. This is just total nonsense. And the reason they make it sound like they figured it out, they didn't figure out anything. A new study reveals the laws of physics. There is no laws. The laws are based on false premises. The laws of physics don't prohibit room temperature superconductors, rekindling hope for a technological revolution. Well, you can hope all you want. It ain't going to happen. Impossible. Heat is resistance. As soon as you have the heat, this normal ambient temperature, you have a lot of resistance. It's just the way it works. The colder it gets, the less resistance. And I know this for a fact because I studied, well, I was instrumental in figuring out why these original chips exploded when they put them in at 17 volts. And the reason why is because when they were cold, they would explode. And this is what happened. They were sent to me to put in the field when they first came out. A General Instruments 17 volt chip running adding machines. At that time, they weren't even computers, they were just adding machines. And they sent them to me in Connecticut to test out. To go to like Aetna and Travelers and all these insurance companies. They had huge amounts of requirement for these calculators. So when they sent them in, we tested them all out and they were fine in the shop. And we put a test tape in it showing that we tested all the functions and so forth. And then the guys took them home in their cars and we're going to deliver them the next morning to here and there. And they did, and they all exploded because it was in the middle of the winter. Up in Connecticut, it gets to 30 degrees, 35 degrees, 25 degrees, in that area, whatever, but they were cold. They left them in their car at night. They didn't carry them inside. They left them in their car. In the morning, they came in and plugged them in, and pow, just like that, instantaneously, gone, done. And so they all came back when I said, they all exploded. I said, what the hell is going on? And the only thing I could relate it to was the only thing that was different from when we tested them in the shop. When they tested them, they were cold. So I started looking into the difference in conductivity between a 70-degree wire, basically, and a 35, well, it was the motors. I was testing on the motors because then you could see it easily. I had a dual trace scope and I could see the difference between the cold and the hot. And the cold would go whoosh, it would suck up electricity like unbelievable because it didn't have a whole lot of extra electrons to create resistance. The warm one would just take on the electricity slowly and it wouldn't damage the chip. Chips, the wires inside the chips are microscopic so that they can't take much electricity. The ones that were cold, they were just flooding through there and they just too much exploded. If you look it up, General Instruments 17 volt chip, and they'll tell you, yes, we had a problem with the environment, they call it. I guess when I went to look it up just a while back for some reason, I looked it up and yeah, they agree, yes, there was a problem, but it worked sometimes and sometimes it wouldn't work. The only time it worked is if it was never cold. They said it had something to do with the environment. Yes, it was when it's cold, it just absorbs too much energy. So you're never going to get room temperature superconductivity. It's just never going to work. That was 1970, 73 or something, or around there. When the first electronic calculators came out, they were the first ones that came out. And they had, like these here, hold on. You see this? This is what the adding machines used to look like. You see? If you want to turn the printer on. This was top-end stuff back then. I still use it. It works good. You see this? I asked, did General Instruments have a 17-volt chip that wouldn't work when it got cold? Yes. General Instruments did have a 17-volt chip, specifically voltage regulator, that had issues with temperature sensitivity. This problem became more noticeable in colder temperatures. Yes, the chip would fail to work properly, no, explode when exposed to colder environments. When they were talking colder, they made me probably 50 degrees, something like that. These were frozen, basically, and they just literally exploded. The top of the chip popped right off. It was a known issue in certain GI components from the past. The problem was mainly due to the design limitations of the chip and how its components responded to environmental factors like low temperatures. It would lead to instability. Well, it wasn't instability, it was explosibility. Now, I would think they would want to take this into account with some of these new quantum chips they're talking about. Somebody just made a chip that's 1 billion times faster or something like that, 1 million times faster than its predecessor. The only thing I can think of, there's a couple of different ways they can increase speeds that don't require miniaturization of the components, but they're so miniaturized now, it's amazing to me that they can work in cold temperatures. And as far as I know, they do work fine in cold temperatures now. But this was just stunning when they all exploded. I was the guy that came out of the Army from servicing Nike Hercules missile sites. They thought I was I knew what I was doing. So they put me in charge. I was the field engineering manager of. Field engineering means you got to fix it when it goes bad in the field. But that's what I did in the Army. So anyway, it was a shock. But within 24 hours, we had it figured out. But all you could do was say, don't plug it in when it's cold. But that got us out of it anyway. And of course, then they reduced the chip's voltage down to 5. So at 5 volts, I don't think you can get in trouble. And they may even be lower than that now. I don't know what voltage they run on. But that time at 17, it was just too much push. All right, there's the boss. I got to go.